Hello, welcome to our YouTube channel on object-oriented design. In today's video, we are going to focus on an important concept called inheritance. So this is part 4 of our object-oriented design series. Inheritance is a key feature of object-oriented design and object-oriented programming that basically allows classes to inherit properties and behaviors, and we are going to look at how, right? So we're going to look at what inheritance is, the basics of inheritance, how to implement it, what are the benefits where you can apply, and basically build a mental model if you want to design your object-oriented questions or even in your real-time world, like real-time applications, how you can do that, right? So let's get started. What is inheritance? So inheritance basically allows one class to inherit properties and methods from another class, right? It's a simple process. So if you take an example, that will be easier to understand. So basically, if you see here, we have a super class which is called animal, and there are three child classes: cat, dog, and cow, right? So the super class basically defines its own attributes and its own methods. Like in this case, animal, the attributes are name and age, and the methods are eat and sleep, right? And then there are some other subclasses of animal which are cat, dog, and cow, right? And these three subclasses are type of animals. So you can also say cat is an animal, right? Dog is an animal, cow is an animal. So the is a is a part of inheritance relationship. So whenever you are thinking of designing classes, think of a relationship between entities where one is another, right? Is a another object, right? So but here you can also see one thing, that inheritance is not just about inheriting the exact same thing, but you can also extend the behavior, right? So for example, in the cat class, if you notice, it is already inheriting the method sleep, but it is also extending that by implementing another method called meow, right? So the meow method is not there in the animal class. Same for dog, right? It is inheriting the eat method, but it is extending the class by implementing a new method called bark, right? So that is what inheritance is. Now let's take a look at an example in code. Basically, if we have to model this example in code, how will we do that, right? So the basic animal class, so there is a blueprint of how you model inheritance. You first have to define the superclass, which is the animal class. In this case, we have defined a couple of attributes, like which are name and age. We have the constructor animal, which is taking in name and age as parameters and setting the values, and we are defining two methods, eat and sleep, right? And inside we are just printing out the values. Then once you have defined the superclass, you then have to define the subclasses. Subclasses extend the superclass. At least in Java, it uses the word extends. We'll take an example of Java here because it's very simple to understand. It's a pure object-oriented programming language. So if you see class dog extends animal, right? So basically when it extends animal, it is already inheriting all the things that are there in animal class, right? So in the constructor, the dog class does not itself has to implement the constructor. It can directly call the super class. So the super class of dog is animal, and in the super classes constructor, animal is already constructor is defined where you are setting the name and age, right? Apart from that, it is implementing a new method called bark that we mentioned, right? So which is not there part of the animal class, and it is overriding the method eat, which is already there in animal, but in animal the method eat is very generic, right? In the child class eat, you want to override the method for its own implementation. You don't have to exactly copy or use the implementation that is there in the superclass. So here the dog class is basically overriding the implementation that is there in the superclass eat and implementing its own method. Instead of in the superclass it was animal is eating, now they are changing that and printing dog is eating, right? So basically you define the subclasses, and you can also customize the subclasses. Similar thing you can do with the cat class also, right? We have a new method which is called meow, and we are also overriding the sleep method from the animal class, right? And then you basically use these class structures to instantiate an object and use the superclass and the subclasses in your program. Basically define the superclass, define the subclass, customize the subclasses if you want, extend behaviors if you want, and then instantiate and use them in your objects. That's a blueprint of using inheritance. Now, if you have to use a main program to see how it works, so this is a simple class with a main function where we are instantiating an object animal and giving it the value animal and age 5. The name is animal and age is 5. Then we are instantiating the dog object and the cat object with different name and different age, right? Then we are printing out the values. So let's see the first instantiation. So when we are using the instantiation, basically here we are instantiating the animal, dog and cat classes, right? Then we are printing out the values of animal's name and invoking the function animal.eat. This is going to output animal because animal.getName, name is animal, right? And animal.eat will give you animal is eating, which we saw in the previous slide, right? In the next phase, we are printing the dog's name and invoking the two methods in the dog class, which is dog.eat and dog.bark, right? That is going to output the dog's name, and the outputs for dog.eat and dog.bark will be dog is eating and dog is barking, because remember we have overridden the eat method in the dog class and extended the dog class to also implement the bark method, right? Similarly, for the cat class, it is going to print the name and cat is sleeping, cat is meow, because we have overridden the sleep method in the cat class, right? So that is how basically inheritance works, but there are certain benefits that you must know of inheritance. Obviously, one of the thing is code reusability, that you can understand. Inheritance allows you to use code from existing classes, which can save time and effort in development. You can also define common properties and methods in a superclass and then inherit them in multiple subclasses, right? Avoiding a lot of duplication of code. So code reusability is definitely useful. Second thing is modularity. Inheritance actually promotes modularity by allowing you to encapsulate specific behaviors in a separate class, right? So this makes the code base very easier to manage, understand, maintain. Also for new engineers, if there is code that is written say 4 years, 5 years before, it is very easier to navigate through the code, right? Next is polymorphism. I've also linked the polymorphism video in the description, and it will also be there in part of the playlist. You should take a look at that. But basically, inheritance enables polymorphism, right? Which means objects of different classes can be treated as objects of a common superclass, right? Like dog is an animal, right? So this promotes obviously flexibility and extensibility in your code, right? And also very easier to model real world entities and relationships, because not everything is unique. You want to create entities and relationships and define structures in your object oriented design which can be reused. That is what folks look for, and that is where the design aspect comes in, that you are able to think of the object oriented, like the objects and the entities and the relationships in that entire project at a low level correctly, which can model future objects also, right? If in this example itself, if we had started with an implementation of dog class and then say 6 months later we had another use case and we implemented cat, right? So at that point of time, we every time had to implement the eat method, the sleep method, all those methods, right? But whoever designed this thinking of future, and that is why they first designed the superclass, which is an animal, and defined certain basic properties and methods which they know that if there is any type of animal that is used in the system, dog, today there is a use of dog, tomorrow there is a use of cat, who knows, 3 years down the line there might be a use of tiger, right? You never know. But even if we implement tiger, we know that tiger is still an animal, so certain of the applications or the definitions will still work at that point of time. So that is basically what interviewers look for, and that is what a good system, basically an object oriented design is, right? So hopefully this was useful. Thanks for watching.